Yeah, I've said it a few times this week, but it's always worth saying again. If you come to a tractor show, don't put your hands on other people's tractors. Yeah, somebody went through and flipped all the switches on all of our tractors. They're all dead this morning. So we'll try to jump a couple of them, get them on, but for the most part, we're going to push them on the trailer and worry about them when we get them home. Hey folks, welcome back to Abundant Life Homestead. If this old 1947 Farmall A of mine wasn't having trouble going into the show, it's sure having a lot of trouble coming out of the show. It'll turn over, but it just will not even try to start now. And I can't say with certainty that someone turning my switches on is the reason that it won't start. There's so many things that can go wrong with these machines. But I can tell you that if you flip those switches on and you leave it running for several hours with electricity running through your ignition system, you can easily burn out a coil, burn out your points, burn out your condenser, and many other things. We don't know if that's what's wrong for sure, so before I go to try to use my A again, I'm going back to square one. We're going to go through the entire electrical system end to end today in this video, and then probably in the next video I'm going to go through the entire fuel system. If it runs after that, then we'll start working it again. The first thing I'm going to do is remove the hood. Now, if you're new to these antique tractors, specifically the Farmalls, and you need to remove the engine cover and you're not sure how, don't worry, it's not that bad, and I've already made a short video for you, and I'll include a link to that video in the description below. Now, the next thing I'm going to do from here is remove the spark plugs. Now, removing the spark plugs kind of might seem like we're going out of order in how the ignition system works, but if I'm going to end up taking my distributor off, I want the engine sitting in top dead center first. Easier way to get that engine in top dead center is to pull my spark plugs, and also it allows me to check the plugs and see if anything's going on with them. And I've said it in other videos, I'll show you again. Many of these heads on these Farmalls, the spark plug holes, the wells where your spark plug goes are too tight for a normal socket. International sells a low clearance spark plug socket that you can get for these. I've also seen other guys take regular big spark plug sockets and mill them down. What I ended up doing that works really well, I just went to the auto parts store, and this is a die-hard 7/8 inch 12-point socket. With the thin wall, that 12-point fits right in there on those spark plugs. No need to go buy a new tool, no need to alter one you have. And you shouldn't ever have spark plugs so tight that you can't get them off with a 12-point socket. So we're just going to go ahead and pop all of these out. Loosen them here real quick. That's not bad, got some oil on it. Other than having a problem with it not running when it got hot, this engine was running real good before the show. And I've got another video that I may not end up publishing because everything I did there I'm going to be doing today, but I've got another video where I kind of narrowed it down to the condenser going bad. But otherwise it was running really good. And these spark plugs look decent. They've got a little oil on them, they've got a little carbon on them, but not bad. Not bad for what you normally get out of an 80-year-old tractor. But I'm going to clean those up here in a minute. Okay, now we're going to start testing some of the components in this system. I want to see what everything is doing, if it's doing it correctly, and if we need to make any repairs. I'm going to get this coil wire out of the way. We don't need that right now. And you'll need your multimeter, and I'm going to try to set up the multimeter on a second screen here. You need your multimeter and a few different tools. Got a 1/2-inch wrench that holds this coil down. I just want to loosen it. I don't need to remove it right now. I just want to be able to get to this back side. Primary wire that goes into the coil here. Primary wire that goes into the coil here takes a 5/16 socket. We're going to take that off. So then I'm going to go to my multimeter. I'm going to set it to test higher than 12 volts DC. On my meter, that is 50 volts. I'm going to take my red lead and I'm going to clamp it to that primary wire. Make sure that's not touching any metal. And then I'm going to take my black lead and I'm going to put it on any ground, anywhere, try several places. Make sure I'm not getting any voltage, because right now my switch is off. Best case scenario, we've burned up our switch, but I don't think I'll get that lucky. So with the switch off, we've got no voltage. Now I turn the switch on. Turn the switch on, go to any ground. See, I'm not getting a great connection, but I should be getting 12 volts. Looks like 10 on that. Yeah, I'm getting closer to 10. I'll come back to a different spot here. My battery may be a little low. Yeah, we're looking at 10 volts coming through the wire. Alright, so I'm getting 12, close to 13 volts out of the battery. I'm only getting 10 volts on the primary wire coming out of this switch, so we're going to test and see what kind of voltage we got going into the switch. Clip that on. Hopefully we're focused there. When I go to the negative battery post, I'm getting that full 13 volts. Find me a ground somewhere else, something I can reach. Only getting a few there, but that's not a... Here we go, we got grounds underneath us. I come to the ground where the hydraulic cylinder is connected. I'm still getting 13 there. So looks to me like this wire coming out of this switch, or the switch, may be burned up. We should probably address that before we go into anything else, because we got to check current and everything else going through that coil. Maybe, just maybe, I'll get lucky and the only thing that's happened is that switch is burned up. We'll test that real quick. I'm going to put this wire back together on it. Let's go ahead and pull the switch out of its socket. Now this blue wire feeds directly to the coil where we tested the other end a minute ago, and we were only getting 12 or 10 volts through it. If we come to this side, if we're getting 12 volts out of this switch, then that wire is burnt up. If we know we're getting 12 volts into the switch and we're not getting 12 volt out, then the switch is burnt up. Alright, we're connected to the switch. Find the ground here. That's, oh, look at that. The same ground I was getting off the green wire and getting 13 volts, going to that same ground, running through the switch, I'm only getting 10. I do believe that switch is burned up. Yep. So, I'm gonna have to go look and see if I have a switch. If not, I'll go to town tomorrow. I've got to go to town tomorrow anyway for well pump parts. I'll get a switch and then we'll continue it from there, I guess. Alright, I picked up a new switch. Let's double check, make sure power's good coming into it. This green wire is what gives us what gives us our current and our voltage into the switch. Clip onto that. Take my multimeter, set it higher than 12 volts. Touch the ground. And we're getting a good 12.5, 13 volts. Okay. Now, unfortunately, I didn't realize when I got this switch, so I took it out of the package, it doesn't have a groove to tell me to show on off on this bevel, on this bezel. I can put that bezel on either way. So we're going to have to test that to make sure we're in the right spot. What I'm going to do is I'm going to take this primary here and I'm going to connect it to one side of the switch. I hope I don't drop these little screws. I'll stick it on one side there and then we'll clamp to the other, and we'll use this to test and see if which way the switch flips is on and off, and then we'll decide which wire goes on which side from there. Alright, don't touch metal. So I'll check with it that way first. There I'm showing the full up to 13 volts the way we should. So that's on. This side should be off. I shouldn't be getting anything. Correct. So if I want off, I want off facing this way in the hole. That's right where I want that wire. Okay. Ooh. I just got a little tickle off of something back here. Oh, my hand was making contact with both terminals of the light switch. Wasn't much, but it was a little tickle. Alright. I don't know if I want to spin this little nut on first. Give me just a little bit of space there. And then I'll take this bezel with off facing in the off direction. Even though that's not It's not important as long as we know we got it in the right direction. There's really not much need to spin that on any further than hand tight. It's a little hard to get grip on though. Alright, let's go to the other end of that wire again, back to the coil. Okay, we're back up here by the coil. We've got this blue wire that comes out of the switch. Just to make sure and double check everything, we're going to reconnect our positive lead here to the switch, or to the wire. Make sure it's not touching anything metal. And then we're going to move our multimeter to more than 12 volts. 12 volts DC. And we're going to touch a ground. With the switch off, we shouldn't get anything on the meter. And we do not. That's good. Now I turn the switch on. Let me untangle my wire here. Turn the switch on, go back to ground. We should get that same high 12, almost 13 volts. And that is exactly where we're at. Good. Okay. Okay, so then now we're going to take this, we're going to take the black lead and we're going to put it on the primary winding of our coil, positive side, and we got nothing. Don't panic when we get nothing, because that does mean our points could be open, our points could be separated. First thing we want to do, if we test the coil on the tractor like this and we've got no voltage running through it, we need to go up front to our hand crank and we're going to turn this about half a turn, or about a quarter turn. If our points are open and we have a 4-cylinder, no matter what type we have, no matter if everything's assembled correctly or not, a quarter turn will close our points. And look at that. Points are closed and we have right at the 13 volts. So we're getting good voltage through here. Now we want to take our multimeter, switch our positive lead onto the DC 10 amps. We're going to select DC 10 amps on here. We're going to see how much amperage this coil draws. Now, I don't know about every tractor, but the coils that we put on these tractors should draw between 3.5 and 5 amps. Is that where I'm at here? Yeah. I'm around 3.75 amps is what we're drawing here. And it's going to fluctuate a little bit. That tells me my condenser's working in there, but 3.75 amps, so we are good there. We're getting good voltage, good amp draw through the coil. Now we're going to test the resistance of our coil. I'm going to take my multimeter, put it down on the 1X for resistance on this one. And I don't know about all multimeters, but this one we have to calibrate when we test resistance. We hold our leads together, we move our dial where it's right at 0. Okay. Now we should be calibrated. Let's unplug the coil. Primary winding, we should get around 5 ohms of resistance out of it. Again, anywhere between 3.5 to 5 is good. I may not be making great contact here. Looking for around 3.5 to 5 ohms. Getting just under 3 is what I'm seeing. Just under 3, right at 3. Let me recheck my calibration here. That tends to happen sometimes. After I test once, I've got to recalibrate and test again. Alright, now we're back at 0. Put red on the positive, black on the negative. We should get somewhere between 3.5 and 5 ohms. We are right at 5 ohms. Bring that back a second time. Yeah, we're right at 5 ohms. Okay, that's the primary coil. That tells us the primary coil does not have any break in it. It still could have a short, but it doesn't have a break. Now we're going to turn this to times 1000 on our resistance. Recalibrate it. And we're going to test the secondary winding. So positive here, negative inside, and we should get between 10 and 15,000 ohms. Looks like we're right between 10 and 15. We got about 12,500 ohms. So that doesn't tell me that the coil is good, but it tells me it's not bad in the way that it does not have a short or break in it. I'm going to plug my coil back in. I'm going to remove the distributor cap. And take the cap, take that lever, put it up there, pull off my rotor, pull off my dust cap. Okay, so now I'm just going to check from the coil to the distributor with reset on the low ohms. I should be able to put the red probe on the positive at the coil and just touch the backing plate here, and I should get very similar to what I had before. Yep, a little over 4.5 ohms. Okay, now I'm going to crank the engine till the point's open, and we're going to check that again. Points should open with a quarter turn. Be real close to right here. That might have them separated enough. I may have to move it just a little further. I'm going to test this again. Now I should have like infinitely low or infinitely high resistance. The needle shouldn't even move. And it does not. And that's good because that tells me that my condenser or my points are not shorted out. When these points start to separate, it completely breaks the circuit. There's nothing else touching the back of this plate. Doesn't mean everything is good, it just rules out possibilities of something being very wrong. Alright, I've got the engine at top dead center. And I don't know if you can see, but I've got a black mark here on my distributor. You can see it in other videos that I did on this tractor as well. But the sunshine today may be hiding that. Got a black Sharpie mark right here. This tells me where my rotor should be at the #1 cylinder. And the way I made that mark, with my distributor cap on, with it latched down even, and I took a small square, which I don't know where it is at the moment, ran the one leg of the square right through the center of #3, coil wire #1, and then the other leg of the square comes straight across, and I just made a line there. That tells me where top dead center is, where my #1 cylinder should be sparking with my rotor on. Now, here I am just a little past that, sitting at top dead center. I believe I am right at top dead center. So I'm just a little advanced in timing, which I intentionally did. I had intentionally set up before we went to the tractor show, hoping that I would be able to go on some road drives. Now, road drives didn't happen, obviously. So I'm going to loosen my distributor up, and I'm going to bring that back to where bring this back a little bit. There we go. Now we should be firing real close to right at top dead center. If you want a little advance, you go a little bit this way. If you want a little retard, you go a little bit this way. Personally, when I'm running it for power, when I'm running it to plow, I like it in a slight retarded setting. I still don't know if you can see that mark, but you can see my rotor pointing here. The mark is right here. So we're just slightly, probably only even a couple degrees retarded on that setting. And that's where we will try to keep it. So tighten this up. Let's see which way we go here. Okay. Put my dust cover back in. Put my rotor back in. Put my cover back on. Okay. Now let's back up and get you a little further away here. Alright, so good clean spark plugs. We're going to put these back in. Let's see, I ain't got enough room to do it that way. Now I don't know what is by the book or what others have been taught, but I've always been told with spark plugs on these old tractors, you turn them 1/4 turn past hand tight. That's how I put them in. Now for your firing order, if you get lost, right here behind the coil and the distributor, it says firing order 1, 3, 4, 2. That way you just can't mess it up. I wanted to show you that before I put the coil wire on and cover it. Yeah, we don't want to put the coil wire on yet. Okay, so this is number 1, where we're pointing at top dead center is number 1. This is our number 1 spark plug. It's 1, 2, 3, 4. So I think the longest one will go to 1. And it can loop back around here. Second spot on our distributor goes to plug number 3. And we'll get this one. Hold that coil up, wire up there. Make sure everything's good and tight. Next one around, the one at the bottom. Goes to plug number 4. It'll be the slightly longer wire here. There we go. Run it down here. And last but not least, cylinder 2. Now, before we plug our coil wire in, we want to make sure we got the wire going to our coil. Make dang sure your switch is off before you go connecting this by hand. It won't get you too hard, but it'll tickle. And tighten that up. Okay, power there to the primary. We got our wire going, the distributor from the secondary. Get that good and in there. These boots on these wires are so airtight. I've got to squeeze them, pull them up, let some of the air out, or they just push themselves off sometimes. Doesn't disconnect the wire, just the boot comes off of it. Now we've got everything plugged into the coil. We're going to tighten up the coil mount here. Okay. Well, I guess now's the moment of truth. I said yesterday that the ideal situation would be that just the switch burnt up. And I didn't think I could get that lucky, but so far all the testing, the only thing we found wrong is the switch was burnt up. So, we're going to try to start this up. Make sure we're in neutral. We got a little fuel. Probably going to need a little choke. See what happens. Oh, look at that. Awesome. We'll let it warm up a minute, and I'll kick my alternator and my PTO on, give it a little load, see how it stays running.
Did you get it working?
Oh, it's running, ain't it?
Yeah.
Yeah. Yeah, it kind of sounds like I need to turn my jet up a little bit. Idle jet. I get about right there. That sounds real good for idle. Got PTO on now. Coil's hardly even warm now. That's good. Before all this started, it was getting hot. Well, apparently I can get so lucky that when someone comes along, messes with the tractor, flips the switch, leaves it on all night, the only thing that burned up was the switch. We didn't lose any of our ignition components. Now, none of this stuff, as far as the coil and the cap and condenser and points, none of that stuff's really expensive, but it's kind of a pain when something goes out. Now, I'm greatly happy that this is running. I'm still not going to work it hard until I've been through the entire fuel system. I'll do that in another video, but as for now, I think mission accomplished. We went through the entire ignition system. I showed you how to check some stuff, how to test some things, and we once again have a running tractor. So I appreciate you joining me today. Hope I was able to teach you something, and hey, if you're able to teach me something, leave a comment down below. Let me know if I could have done something differently, if there's something I missed. I'm always willing to learn from others. But otherwise, until next time, keep on nourishing your dreams, cultivating your passions, embracing the beauty of God's creation. I hope you have a wonderful and blessed day. I'm going to go drive this around, and I will see you then. Be all easy, but I can take off in second gear, see where we go. Now I'm going to plug my coil back in. I'm going to turn my switch off. I don't need that on anymore.